A very good morning to everyone here on behalf of Quadrant. I welcome you all to this live webinar on AI-powered data quality management. My name is Sandeep Thomas, and I am your host for this event. It's great to be here with you today hosting this important webinar on a key data management topic that's of great interest to all of you. This event is being broadcast on multiple platforms, including LinkedIn, Facebook, and YouTube. So please help us share this event with your peers, friends, team members, and your network connections who can benefit from hearing this valuable information by either commenting, liking, or sharing the link to the live stream. It's my great pleasure to introduce our distinguished speaker for today's webinar, our own Sai Suresh Medicharla, who's the Senior Vice President at Quadrant. Here's a quick intro on Sai. Sai is the Senior Vice President of Global Sales and Solutions at Quadrant. He's responsible for taking a portfolio of solutions to market and for growing our business. He brings extensive consulting experience in leading, managing large complex client engagements for Global 100, as well as mid-market clients across banking, insurance, life sciences, and other industries. Sai blends both strategic and pragmatic implementation perspectives to technology issues, providing audiences with usable and actionable content and advice. Sai will bring a holistic perspective of the relevance of AI and data quality management and how AI can be leveraged for data quality management across the entire data value chain and what some of the key implementation considerations are. At the end of his presentation, we will have a short Q&A session. If you have a question, please type only your question into the chat box. We don't need your name or your firm's name if you don't like to add those. And then hit submit so we can display that question on screen and have it answered by our speaker today. If we cannot answer a question, we can respond to you via email if you provide us with your email address. So please email us at marcoms@quadranttechnologies.com. Without further ado, let's get started, and I invite Sai up on stage to kick things off for us. Over to you, Sai.
Thanks a lot, Sandeep. Thanks for that great intro. Let me go ahead and share my screen with everyone. Good morning, good afternoon, good evening, everyone, depending on where you are. Hope you're all having a great day and a great week so far. Thanks for making time to join us today for this webinar on AI-powered data quality management. Sandeep, please let me know once you're able to see my screen. Can you see my screen, Sandeep?
Yes, Sai, we can see that. Go ahead and go into full screen presentation, and we'll be able to see it.
Yeah, I'm on slideshow mode. Hope this is all.
We're not seeing the slideshow mode, Sai.
Bear with me 1 minute. How about now?
No, not yet. Maybe just share your entire desktop. And
then I'll doing that.
Thanks everyone for your patience.
Can you see the screen, Sandeep?
I can see the screen now, and go ahead into presentation mode.
I am on presentation mode.
Okay, I'm still seeing only the PowerPoint display before.
I'm sorry about that.
Yeah, maybe just share your entire desktop.
Yeah,
and that might be better. Perfect.
How about now?
Oh, yep, we can see it.
Thank you.
The floor is all yours.
Thanks, Sandeep. Thanks everyone for bearing with that little bit of a delay, but thanks for making time to join us for this webinar today. Here is a quick outline of what we intend to go over with you in the next 40-45 minutes. We'll start with a brief look at what makes for good data quality. We'll then see why we need artificial intelligence in data quality management, which I believe is all too obvious, but I will look at some objective criteria as to why we need AI in DQM. We can then do a deep dive into how we can apply AI-enabled data quality management across the entire data value chain in an enterprise, followed by some inspiring examples of how some of the leaders in the industry are using AI-powered or AI-enabled data quality management. We'll wrap up with a review of what some of the key implementation considerations are. And then we can also do a quick brief on what we at Quadrant are doing in the space. And that's pretty much the agenda for today, and hope that sounds like an interesting plan. So let's jump right in. So what makes for good data quality at a basic level, right? So this webinar is not really about terminology or definitions or talking about the data quality philosophy, but it's worth spending a minute or two to have a common understanding, a common ground in terms of what data quality really means. We do have some definitions on the screen that you can see from some of the key players in the space, IBM Informatica, a couple of examples. I like the IBM definition, which is a little more holistic. So they describe data quality as demonstrating all of these key characteristics that you see here. It is about data accuracy. It's about making sure you are able to provide data that is factual, that is accurate. So if I'm saying Quadrant is located at 4034 148th Avenue Northeast in Redmond, Washington, that should indeed be a fact, and that is the accuracy that we're talking about, in terms of representing the real world information accurately through your data. Data should also be complete without any missing records or missing values. Data should be timely. If in a typical enterprise, if a client has placed an order for one of your products or services, the sales leadership should be able to see that information pretty much within the same day, probably within a couple of hours, if not shorter, giving it a little bit of a processing time, right? So that's the timeliness that we are talking about. Data should also be, it should also provide qualitative characteristics. For example, trustworthiness. I mean, if your business cannot trust your data, all the effort and energy that goes into your data management is probably not worth it, right? So how do you achieve trustworthiness? It's a qualitative issue. And we need to look at how you can measure trustworthiness and how you can demonstrate trustworthiness in your data. Likewise, we have several other criteria here: consistency, validity, usability, relevance, and others. These are all the characteristics that your data should demonstrate in order for you to say that your data is indeed of good quality. The way that you can demonstrate good quality is not just having a qualitative or a good feeling about a good confidence informally, but through specific measures and metrics that you can report back to your internal stakeholders, as well as to other parties that are interested in your data, to make sure you are quantitatively proving the quality of your data. Right. So, if, for example, if you're looking at source target comparison, you should be able to prove that you are bringing in all of the records that you have in your source data sources into your landscape. You should be able to prove which should prove that the data is indeed trustworthy, or the users find it usable data and relevant data. So it's a combination of quantifying some of the qualitative measures is how you can demonstrate that your data is indeed of good quality. So if you are saying you have good quality data within your enterprise, you should be doing all of these already. Or if you are a person that is responsible for data quality all by yourself within your organization, you should have probably got a promotion in the recent past, which is good enough proof that you are actually doing a good job in terms of delivering good quality to your business. So that's really how we can determine the quality of data in your landscape. Let's look at why it is important to have good quality data, right? I mean, it's a no-brainer, but it's surprising to find that even some of the largest organizations are probably not spending enough in this discipline. There are probably not enough investments in terms of a dedicated function or a dedicated set of people that are driving some of the data quality efforts. There are probably very few companies that do that as a very focused discipline, even in some of the largest organizations. That seems like an irony because these days, most business decisions are made based on data, right? For example, your budgets for a new financial year are not approved without a thorough analysis, diligent analysis of your previous year's budgets and how that money was spent, right? So data plays a key role in business decision making. So there is all the more reason to make sure you have good quality data and trustable data. A lot of companies are leveraging data to make a big difference in terms of how they take their products and services to the clients. In fact, large deals are won on how data is leveraged to do business with clients, right? So it's a key determinant in terms of the business growth and the profitability of the company. And we look at some of the marquee names in the industries, the likes of Netflix and Amazon and several other technology leaders with adoration and admiration because of the way they have been able to leverage data to innovate, to monetize data to a large extent, right? So there is a great opportunity, and if organizations are not focused on that, if they're not leveraging such opportunities through data, then you're missing a great revenue opportunity. One thing that is probably a place where everyone is converging, there is a lot of common interest across industries, across domains, is the AI ML space, right? There is no industry, there is no company that is not interested in AI ML. There is so much activity that is going on, and the simple fact is, you cannot do any of that without good data. So any organization that has even a little bit of interest in this space need to be thinking about good data quality practices. Last but not the least, if your business stakeholders, if your internal users, if your internal consumers, customers of your data don't trust in your data, then that is a huge drain on your data management team. Because then it's about proving to the business that the data is indeed trustable data, indeed accurate data, and the number of cycles that data management teams need to go through the process of proving to the business is tremendous, and that's just not worth the time and effort. And last, there are many instances, there are many bad experiences that the industry has gone through. There are way too many data breaches in the recent past, resulting in millions of dollars of penalties that companies have been paying. That is just not worth the investments. That is just not worth the negligence that the companies express in terms of paying attention to data quality management. So it's time that companies pay a lot more attention to data quality and make the right investments. Companies don't need to wait for a bad event to happen in order to pay attention to this particular discipline. So why do we need AI? And we all agree that data quality is important, but then what is the relevance of AI to data quality management? Um, you know, you probably are already dealing with some of these issues within your respective organizations, and this is not new to many of you mostly. But the data landscapes across companies are becoming more and more complex. There are a lot more applications that you're dealing with today. There is a lot more data volume that you're dealing with today. You probably have data on multiple clouds, some applications residing on AWS, some applications residing on Azure. You probably have a lot of data coming from your partners. So the data volume is just exploding, right? And you also probably have a lot of SaaS services. You probably use Salesforce. You probably use ServiceNow. That adds another dimension to the data complexity. So you have to deal with data not just on on premise, not just on one cloud, multiple clouds, on premise, external sources. So you're dealing with a lot more complex data landscape, both in terms of volume and in terms of the complexity of how you bring that data into the enterprise and how you process that data. The second aspect of it is today's business is moving at a breakneck speed. Right? Your business is asking you to deliver your ongoing support services without any interruptions. You're supposed to take care of all the ongoing data management and reporting on a day-to-day basis. But at the same time, you're also expected to deliver innovation, be it in terms of as a new data science project, a machine learning project, or an innovative self-service reporting capability that your business is asking for. So how do you balance both the run as well as innovation services at the same time? That adds another dimension to the data quality challenge. Typically, a lot of companies have started on the data quality journey probably many years ago. And some of those efforts probably would have been in a modest way in terms of using some custom scripts that you've written internally to do simple profiling, simple validation, simple matching of source target data. But that just doesn't cut the ice in terms of addressing the complex needs that you have today in terms of dealing with the complex data landscape that you have. The different sources that I talked about, the complexity of data that you have to deal with, it's just not possible to manage data quality with simple tools that you probably have started off your data quality journey with many years ago. The other aspect of data quality, the relevance of AI in data quality is to do with talent, right? Given the multitude of data platforms and data technologies that you deal with, it's almost impossible to find the unicorns that you need with all the expertise and experience across all of the different data platforms that you deal with. And the challenge is going to grow even more because of the spurt in AI, ML, and generative AI type of engagements, projects across companies, and that's going to call for even more needs in terms of multi-skilled talent. And that's going to only grow in the coming years and in the near future. Lastly, the advanced capabilities that AI can deliver are just not possible to match up in terms of any manual methods or any traditional methods, in terms of being able to recognize patterns in data, in terms of using capabilities like anomaly detection and proactive predictive capabilities to enhance the data quality within your landscape. So that's a clear case for using artificial intelligence in data quality management, and I'm sure you probably have experienced some of it or all of it within your respective organizations. So let's look at what it means to apply these principles to a typical data landscape, right? So what you're seeing on this page is as a typical end-to-end data landscape in any large organization. This is not a logo puzzle. You see a number of products that you probably are familiar with. This is just to make use of the slide real estate in an efficient way. So as part of your typical landscape, you have a number of transactional systems, your line of business applications, your ERP, your CRM, your service management systems, and each of them, is as a data source for your data management platform, right? You probably have a lot of relational data. You have data on the cloud. You probably have a lot of Excel data too, right? And then if your enterprise uses a lot of the unstructured content, such as email content or document content, that's another source of data. And then you're bringing the data using some of the data ingestion tools and technologies. Maybe you're using Informatica, maybe you use Azure Data Factory, Fivetran. All of those are tools that you will see within your enterprise today. And you have most likely have a data lake where you're bringing in all of this data into, and then you are running data transformation using some of the tools like Databricks or DBT, and then you are sending that data to a data warehouse, either on-premise or on cloud. You probably also have a number of data marts, and then you probably have your reporting layer, right? So this is typical of pretty much any large organization. And the key fact is data quality is not a single point or a point in the end-to-end process, but it is a continuous capability that you need to bring in, and there are data quality checks that you need to do at every stage of the end-to-end data lifecycle. For example, at the ingestion layer, you probably are looking at profiling data, and then defining a specific golden record type of a measure to make sure everything that you bring in into your data warehouse or data lake matches with that golden record definition. You probably also have a number of other rules that you want to apply to any incoming data before you process the data through downstream processes. The source target comparisons also obviously need to take into account record counts, attribute values, timestamps, and all of those are part of your filtering process before bringing in data into the data landscape. Now, the data quality puzzle gets a little more challenging as you move deeper into the into the landscape in terms of what you need to do. For example, if you have to test the data after it has gone through data transformation, you need to figure out a way to see how you can test the data or check the data for things like what the transformation process has done to the data. Has there been standardization? Has there been aggregation? Has there been some rules-based conversion, right? So it is one thing to be able to do source target comparisons, but if you have to do checks on transform data, how do you achieve that? How do you achieve that at scale? That's not an easy task, and it calls for some advanced capabilities. And then going into the data warehouse layer, you need to do probably the same things that you did with your source target comparison. You probably need to look for all the attributes, all the records, non-null values, unique primary keys. But again, what the real issue here is that you now need to do that. Whatever you did with the source target comparisons at the ingestion layer, you probably need to do all of that, but taking into account the transformation that has happened on the data, right? So how do you achieve all of the checking, all of the testing for transformed data in a data warehouse, taking into account all of the key requirements of accuracy, consistency, timeliness, and all of that? And then when you go to the report layer, it gets a little more interesting, right? Now you're talking about not just data, but also in terms of how the user is experiencing the report consumption, right? So you probably have a lot of interesting reporting tools, but how do you make sure whatever data you are delivering as part of your reporting is indeed accurate? How can you make sure not just the data is accurate, but also the reporting capabilities are functioning as they're expected to function? For example, how are the drill throughs working? Are the totals, are the column totals accurate? Is the data traceable? Can you trace the data all the way back to the source from the report? So those are all the key capabilities that you need to look at in terms of doing data quality checks in your reporting layer, right? So data lineage is another key aspect that you need to look at in terms of reviewing data quality at a reporting layer. So these are all the key aspects that require advanced capabilities. Now let's jump into the real meat of the conversation, which is applying AI, right? So here is a quick refresher on what AI is. I'm sure all of you are more deeper into AI than what you're seeing on this page, but just to get us grounded, the relevance of AI to data quality management is really in terms of the different layers of AI that we have here, starting all the way from data science to artificial intelligence to machine learning, deep learning, and the underlying algorithms or models that we have supporting all of the AI capabilities. So this is the models layer is what is probably very important in terms of addressing some of the data quality needs. Right. This is what drives some of the advanced capabilities that we need for AI-enabled or AI-powered data quality management. Some of the models that are being used by some of the established players in the data quality space, as well as some of the open source capabilities that are out there, most of them leverage one or more of these underlying models to drive the data quality capabilities. So here is a look at some specific data quality related AI capabilities and what they enable in terms of the specific data quality functions they perform. Right. Thankfully, there is a ton of work that is already done by the open source community. If you're looking at commercial products, there is probably a lot more advanced capability that you can look at in terms of how AI can enable data quality management. I'm sorry, I have to just take a quick pause. I really apologize for this. I need to plug in my battery. Apologize for this. My apologies. So if you have to look at some of the key data quality needs, especially in the um, data source to target ingestion, you need to look at ways that you can do checks for inconsistencies, outliers, missing data, unusual patterns at scale. I mean, you're talking about ingesting large volumes of data, and that is impractical to perform with manual means or simple script based type of analysis. That's where capabilities like anomaly detection can make a huge difference in terms of how you can apply AI capabilities at scale to bring in good quality data into your landscape. Natural language processing and LLMs are playing a big role in terms of how you can look at text-based analysis. If you're looking for ways to make sure you're able to apply semantic consistency, you're able to analyze your textual content to make sure you're able to do comparisons between source and target for text-based content, for language consistency. All of that is indeed supported by natural language processing capabilities that are readily available through a number of NLP libraries that are already available. There are a number of algorithms as well as ready-to-use libraries that are made available by the open source community, and that is indeed a key capability that organizations can leverage in terms of readily applying AI capabilities. There are other capabilities such as named entity recognition. There are indeed services. I mean, for example, if you have to look up, location information, that is a service that providers are already offering as a ready-to-use service. So those are the kind of capabilities that you can integrate into your AI-enabled data quality management capability, and then you can use those external services to test or check for some of the common validations that you need as part of your data quality processes. There are also number of similar algorithms for addressing things like missing values, imputing those missing values, correcting typos, using some of the purpose-built algorithms such as k-nearest neighbors. The key aspect of AI-powered document data quality management is the availability of a number of Python-based libraries and algorithms. So that's something that a lot of companies have already been using, especially if you're building homegrown utilities for some specific use cases. There is a ton of code that is already available from the open source community through these open source algorithms and libraries. So those are some of the key AI-powered data quality capabilities that are readily available from a number of different players in this space. More examples. The fact is, as it gets more complex in terms of the type of data quality checks that you need to do, for example, if you want to do referential integrity checks between multiple layers, let's say you want to do the referential integrity check between the data in the data warehouse versus the source from where the data came from, you really cannot do that through standard mechanisms. You need advanced purpose-built algorithms that can understand the data context, understand the patterns, and then be able to cross-reference the table structures with source data and be able to provide you confirmations and confidence that the data in the data warehouse is indeed intact and it is of good quality. So there are, again, a number of algorithms that do pattern recognition, graph-based algorithms that show relationships between the various data entities. And, you could also do custom scripts using some of the algorithms that are available. Data lineage is another area where you cannot, use any of the standard capabilities. You probably need to look at building some purpose-built algorithms or some custom scripts. There are, of course, tools that do advanced data lineage. Pretty much all of the data products, the enterprise data products that are out there provide a lot of advanced data lineage and data cataloging capabilities that take care of these types of requirements. So, key capabilities that AI-enabled data quality management and algorithms that are available can provide to ensure you're able to implement these capabilities quickly and seamlessly. So that's in terms of how you can apply data quality management using AI across the entire data value chain, all the way from source data to your reporting layer. Let's look at what some of the popular options are in terms of both open source and commercial AI-powered data quality management tools. So what you see on this page are some of the very commonly available, very popular open source tools and end-to-end data management platforms. So these four are pretty popular amongst the open source community. DQ is a library built on top of Apache, and it helps you basically do unit tests on your data. They also have an API called PyDQ, which is basically a Python API that you can embed into your your own processes, your own data quality processes. DBT Core, which is, DBT is pretty popular as a transformation engine, but they also have it's basically an open source platform, but they provide automated data testing. This is not very well known in the industry, but DBT Core does provide a lot of automated data testing. You can do full scale quality checks, validation. You can actually align your data testing to each pipeline. So if you have, pipelines built for each type of cloud data source, you could basically align the test or customize the test for that particular data source. So that way, it's a very powerful tool in terms of making sure you are doing automated testing, automated data testing on a data source by data source basis. The other one is MobiDQ. It basically provides all the capabilities of a typical commercial product as part of an open source platform. And similarly, SodaCore is also a fairly robust automated AI-enabled data quality testing tool. It provides observability, reliability, and all of those capabilities. When it comes to the commercial tools, these are all the platforms that not necessarily provide only data quality management. They are more like enterprise data management platforms or tools. And data quality management is one of the components of each of these platforms. So the nice thing about them is that you are able to integrate data quality with the other capabilities in the data management area. Meaning, you are able to integrate data lineage, for example. You are able to integrate data cataloging, for example. So what that does is, you get even more power in terms of making sure you are able to tie back into, for example, lineage can be used as a data quality capability for making sure you're able to trace back data at every point in your end-to-end data lifecycle to the source data, right? So that in itself is as a data quality capability. And if you have to do that on a standalone basis, you probably need to spend a lot more effort in just implementing data lineage as a capability. Likewise, all of these platforms, be it Informatica, Talent, Atacama, Colibra, they are all pretty robust platforms. There are many more in the market, of course. We're only capturing a few of them just to give you a perspective of what is available and what is possible to do with these platforms. And each of them provide the ability to automatically discover relationships in data. They are able to connect to a number of data sources. Some of them support upwards of 50 plus data connectors to connect to a number of on-premise and on-cloud data repositories. There are a number of capabilities in terms of automatic detection of inconsistencies, pattern recognition, null value detection. They also support the most important aspect of being able to recognize the relationships between tables. The transformative data checking is another capability that most of these tools support. Obviously, there is a cost to it. If you have to build your own data quality solution using any of the open source platforms or open source libraries, it is probably cost effective, but it's way more time consuming, and it could take you months to build comparable capabilities that you find with any of the commercially available products. So it's really a trade-off between the investments that you need to make versus the capability that you can get versus the amount of time it would take you to implement those capabilities. Let's quickly look at some of the inspiring stories from the industry. Right, this is a capability that's been in use by some of the industry leaders for some time, and obviously they have made strides in terms of being able to see tangible, measurable benefits from their DQM investments. For example, if you look at a company like CVS Health, deliver reports in 2 to 3 days instead of 6 months that they were taking previously. That's a huge achievement, and that might not be a great benchmark or a great a big bar for many of the other clients who want to see reports in hours, if not minutes. But it was a big jump for CVS Health, given that their historical reporting delivery was pretty lax. Another interesting story is T-Mobile, the mobile service provider. They had petabyte scale data volumes, and it was impossible for them to identify PII data within that large volume of data. And they use, I believe, Atacama, I believe, the commercial data management platform, and they were able to save up to the tune of $350 million in terms of cost avoidance. As I said earlier in the presentation, the cost of bad data failures is humongous, and it's no wonder that T-Mobile is able to save that big a dollar amount in terms of cost savings through data quality management investments. Some of the other examples are fairly well known. For example, LinkedIn uses AI to a large extent for doing data cleansing, improving the quality of data in the user profiles. They have a number of algorithms that do a number of consistency checks, accuracy checks, duplicate information, and all of that to make sure user profiles are tight, and they represent the right information, the accurate information, timely information. So that's a well-known capability that many of us probably have heard about. Walmart is obviously known for their ability to integrate AI into their operations. That they've done very effectively on the supply chain side to address the challenges they had with data coming from multiple different partners in terms of the data transfer from product vendors, product manufacturing companies, their other supply chain partners. So they were able to implement AI-enabled data quality management to seamlessly integrate their partner data into their supply chain analytics capability, and thereby they're able to do much better inventory management, much better logistics management, and obviously there is a lot of savings there too. We just don't have the specific data about that. We have a couple of other examples in terms of how another healthcare company is able to cut down the time they spend in terms of reconciling some of their healthcare provider payments using automated data quality management. This is a big issue for a lot of healthcare providers, where the insurance companies go back and forth with them, and a lot of times there is a tremendous amount of time that is lost in reconciling the claims that are coming from providers. And unless you have a seamless data quality process, a data quality framework, you cannot really have good relationships with your providers because of payment issues and the amount of time it takes to process some of the claims. So this company, Community Health Choice, was able to implement Colibra data management platform, and they were able to achieve this 59%, 60% improvement in accuracy in addressing the healthcare provider claims. So those are some of the interesting examples from the industry in terms of how they've been able to use data quality management to kind of advance their capabilities and deliver real business value in terms of better customer experience, better revenue management, addressing leakage and costs, and several other aspects of business. A quick look at what companies need to do, or what some of the key considerations are when it comes to implementing data quality management, especially AI-enabled data quality management. So the first and foremost is, if you are a big enterprise, if you have advanced capabilities within the organization, you should probably look around and see if there is a big data management platform such as an Informatica or a Colibra or a Talent. And that would be a great starting point, because most of these platforms already provide those advanced AI-enabled data quality capabilities. If there is no such platform available within your company, or if you're just starting your data quality journey, it is probably a good idea to look at what are some of the most pressing challenges within your data landscape. For a lot of companies that are just starting off on this exercise, the first place to start with is a good data profiling and data filtering capability. That is pretty common with any client wanting to do this type of an initiative. You and then you prove the capabilities, you prove the value to business, and then you go for scaling your capabilities across the enterprise. So even to do that, you need a project that is really compelling, that can deliver real value to your business. So you should probably look at an application area or a data set that has mission critical impact, right? For example, if you're looking at auto fulfillment area, or if you're looking at financial accounting area, those are areas that have big impact in terms of what data means in those domains. So you have a better chance of success if you focus on some of those mission critical areas, and then you have better chances of getting sponsoring or funding from your CFO's office. Most importantly, you've got to deliver the project. You've got to prove the value, right? So look at a project that has that potential to deliver value, to prove to the business that it is worth investing in data quality management as a capability. And then once you've done that, you probably can look at scaling your capabilities across the enterprise. But even then, I think it's probably wise to look at what is the order of prioritization, right? So you can look at this prioritization that we are suggesting here, starting with data profiling, data filtering, data ingestion quality checks, and then moving to more advanced, more complex data quality checks, be it in terms of data transformation quality checks or lineage and traceability, and then making it an end-to-end data quality capability across the enterprise. Last but not least, I think the approach should be that even if you're starting small, think big in terms of how you can scale the solution, how you can build an end-to-end enterprise level data quality management capability, rather than a simple point solution that you can implement fairly quickly and easily. So you should go with the big picture in mind, even if you are approaching it in a very tactical way. So those are some of the practical considerations in terms of how companies should go about implementing AI-enabled data quality management. So just to close out this conversation, we are leading the way at Quadrant in the AI space with innovation. We've been building a number of solutions leveraging some of the latest technologies, be it generative AI or your traditional AI and ML models. So we built a AI-powered data quality management solution using a combination of generative AI, LLMs, as well as statistical analysis, statistical modeling tools. And we've come out with a solution that can discover patterns and relationships in data, any kind of data. The data can be on cloud, it can be on premise. We're able to connect to a number of different data sources. And the beauty of the solution is, even if the structure of the data is not known, the solution has the ability to intelligently discover the patterns and relationships in the data, and it automatically prompts you with a number of data quality rules, which you can then review with a data owner or a data steward can review those data quality rules and then select some or all of them. And then once committed, that becomes a basis for bringing in any data into your data warehouse or your data lake. So all of those data quality rules then get applied to the ingestion process, and you can be sure that whatever you're bringing in is a fairly good quality data. You can specify business rules on a data basis, so that way you don't have to worry about whether you've overlooked some data, overlooked a particular data source, and paying attention to the others. So you can pretty much set up these data quality rules for all of your data sources, and then we have an intuitive UI to manage the entire configuration, be it in terms of connections to various data sources. You can do versioning of the data quality rules. If the data changes over a period of time, then the solution has the capability to automatically discover what those changes are, and it prompts for any changes that you need to make to the data quality rules. So that way, it is an evolving capability. You are not stuck with a static data quality capability, but your data quality solution can evolve with you as your data grows, as your landscape becomes more and more complex. So that's what we have. Hit us up on LinkedIn. You can also send us an email to markams@quadranttechnologies.com, and we will be glad to schedule a demo with you and show you. and hopefully we'll be able to help you with data quality journey. So that's what we have for today. Let me pause and see if we have any questions from the audience.
Thanks, Sai, for that insightful presentation. I got a few questions here sent to me personally. Let me just put them up on the screen so that you can see them. And if there are any more questions, please do enter them in the chat field. Whether you are streaming in from Facebook or LinkedIn or YouTube, we should be able to see the comments here. But here is one question that we got. Just show that here. There we go.
Good question. I think the typical challenges in terms of implementing AI for data quality management is sponsorship and support within the organization. And also there is a level of expectations that need to be set. The moment you talk about AI, the expectations go up, pretty rapidly and significantly higher, right? There is an expectation that everything is in ship shape, and everything is automatic, and you don't have to do anything. But that's not the reality. The implementation is a tough road, and you need to make sure the stakeholders understand that, and there is a gradual maturing of capabilities than an overnight miraculous change of things. So that's the key expectation that needs to be set in terms of how organizations can prepare for success on some of these initiatives. The other aspect of AI and data quality management is you need to have a solid grounding in your basic data management capabilities. You cannot expect to apply AI in data quality management if you don't even have some of the basic hygiene in your data quality processes. You need to have some in terms of how your data goes through your various data lifecycle stages, whether there are some guardrails in terms of who has the ability to promote data from, let's say, your staging to your data warehousing layer, or from your who approves changes to your connectors, who approves changes to your ingestion layer. Those are some of the key capabilities that you need to have. You must even if you have to think about data quality management as a capability. So just to summarize, basic capabilities, basic data management capabilities, and some discipline, sponsorship within the organization, and managing the expectations of your stakeholders. And then the other aspect of it is choosing the right implementation approach. For example, if you are a large enterprise, and if you already have a mature data management platform, you probably would want to use that for building out your AI-enabled data quality management platform. Whereas on the other side, if you are a mid-market player, and if you cannot invest in a big platform, which might cost you maybe upwards of $500,000, then you need to look at what are some of the open source capabilities that you can leverage. But again, that also depends on whether you have talent internally within your organization, at least few Python developers with the ability to use open source code and build solutions. That's another approach that you can take if you really cannot afford a big data management platform. So that's where I think point solutions like the ones that we have make sense. We are primarily addressing the mid-market segment, where you don't need $1 million data management platform, but you want to address some very specific data quality issues. You can look at point solutions like that, and then you will be able to address those in a fairly short period of time. Data minimization, ensuring privacy and security. Does this lead to lack of data in training AI models on pre-data sets? How we overcome this? Very good question, Sunil. Data privacy is indeed a big concern for many organizations, as is ethical concerns. So the way it is addressed is, again, it goes back to what's your implementation approach, right? If you're going with a big platform, some of these concerns are already addressed, as part of the platform capabilities itself. You cannot imagine, going to a Informatica or an IBM data quality management platform and expect to have, security issues or privacy issues. That's fundamental and foremost for any data quality management capability. If you are wanting to build out your own data quality solution, then you need to specifically address these capabilities, and you probably need to pick tools or algorithms or libraries that provide some level of confidence in terms of their ability to provide private data privacy, security, and even freedom from bias, right? You cannot introduce bias in your AI models when it comes to data quality. It might be a purely technical implementation, but I think even there is potential for bias, changing the way the system would behave over time. So those are things that you need to build into the data quality solution that you're trying to build. And some of the algorithms and libraries that I mentioned during my presentation, there are several libraries that you can use to ensure your data quality solution is indeed implementing the privacy and security checks as well. I mean, that's actually another data quality check that you need to do on your data, right? I mean, you need to make sure only those who are supposed to have access to the data are indeed accessing the data. So data security, privacy is actually a data quality check that you need to build in, either using some of the available algorithms to do that, or you need to look at how the ready-to-use platform is able to bring those capabilities. Hi, Dave. Thanks for the question. I think we started off the discussion with a set of quantitative criteria that we can use to establish that the data quality management discipline is indeed producing good data quality. So we can do that through a combination of quantitative and qualitative measures. The qualitative measures are to do with how do you ensure your business trusts your data, whether users think the data is usable, whether the users think the data is relevant. So those types of attributes can be verified or measured based on stakeholder surveys or feedback from users. So that's about the qualitative aspects of data quality. But in terms of let's say data comparison of data between moving target, record counts, missing values, or consistency checks, those are all measures that we can really measure quantitatively and prove that the data is indeed of good quality. So we need to employ both the quantitative and qualitative measurements to make sure we can prove to the business that the data is of good quality. Hope that answers the question. I'm not sure if you mean by software testing tools, but a lot of the platforms that are out there in terms of the end-to-end data management or data quality tools do provide the ability to do all of these checks that we talked about, right? Be it consistency checks, be it referential integrity checks, be it in terms of deduplication. All of those are capabilities that are already built into these end-to-end data quality management platforms. But if you're looking at custom building your data quality solution, there are indeed tools, open source tools. For example, DBT for one is pretty strong in terms of providing extensive data quality checks on a source by source basis. And also, there's been a lot of published research on how you may be able to use some of the automated testing tools, right? For example, Selenium and Cucumber have been found to be very, very useful in integrating with your data quality processes as well. I mean, Cucumber especially has been found to be very effective in terms of doing automated unit tests and other tests on data quality.
Perfect sign. I think we have time for just one more here. Let me put up the last question.
prerequisites to implementing AI-powered data quality management. I think we talked about this briefly while answering the other question, Sandeep. The primary prerequisite is to have a data management discipline in the organization where you have foundational capabilities in terms of how you're bringing in data, how data progresses through each of the life cycle phases. What are some of the checks and balances? What are some of the guardrails in terms of ensuring some of the fundamental capabilities are there? And then the other thing is about stakeholder management and what the expectations are that you can set in terms of what can be delivered as part of a data quality management initiative.
Great. Awesome. Well, that brings us to the close of our webinar today. And for those of you asking, yes, this live stream was recorded. So please check out our Quadrant Technologies page on LinkedIn or Facebook to watch anything you may have missed. Please do share it with your network, and we can't wait to hear from you. So if you didn't have a chance to register for the event, please put in your name and contact info and the company you work for in the chat so that we can reach out to you with any relevant information. And feel free to contact us at the email address that's scrolling across, marcoms@quadranttechnologies.com. I would like to thank our speaker, Sai, for sharing his valuable perspectives and expertise with us today. I'm sure the audience was able to take away several useful insights from the presentation today. So, Sai, thank you. It was indeed a great presentation. And
thank you, Sandeep, and thanks everyone for joining this webinar today. Appreciate the participation and engagement. Hope to connect with some of you in the next few days. Please hit us up on LinkedIn or email, and I will be glad to engage with you in the coming days.
Absolutely. And just a final thank you to our participants. Thank you for your time, your active engagement, and your thought-provoking questions, and for your commitment to staying informed about a key data management topic. Your presence has made this webinar a rewarding experience for us and hopefully for yourself as well. So we hope to engage with you soon. Until then, thank you and have a wonderful rest of your day.
Thank you. Thanks, Sandeep.
That's